Hello everyone, welcome to today's video. In this tutorial, I will cover the concept of arrays in MATLAB. First of all, what is an array? So array are simply a data structure that stores a collection of elements such as numbers or characters. If I can give you an example how to make an array in MATLAB, I will assign a variable a these six values. I've used space to separate the two values, and if I don't give a space between them, then they will be treated as single values. So here I have created an array which is containing seven values, and the size of this will be 1 cross 7. That can be seen in the workspace as well. And there is one row and seven different columns, and the last value is 75. The next question is why do we need arrays? So for example, if I want to store 100 values of same data types in variables, then one way is to create 100 separate variables like a is equal to 5, b is equal to 10 and so on. Other way is simply I can create an array and store 100 values in it. If I want to access any value or any element of the array, I can simply write a1 comma 3 to access that element. So this makes our task very easy. Instead of maintaining separate 100 variables, I can create one variable and use its indices to call that element. So the array I just created is called as one-dimensional array in technical terms. If I want to create 2D array, which are also known as matrices, I can make use of semicolons to indicate to MATLAB that this variable is having multiple rows. So to give you an example, I will create another variable b and I will assign values 1, 2 in the first row, then 3 and 4 in the second, 5 and 6 in the last row. If I press enter, you can see the variable is created with 3 rows and 2 columns. Now, to access any element, I can make use of the row number and the column number to access that element. Or I can also assign access it using b2. This will also return me 3 as the output. So why this happened was because MATLAB stores the element of arrays in a column fashion. So b1 will be 1, b2 will be 3, b3 will be 5, and b4 will be 2. So I can print b4 for you to show you that. But this is kind of a complex way or the notation to access that element. I would advise you to make use of b2 comma 1 so that you don't end up making mistakes in your code. And that's how I usually do my codes as well. So now let me clear my command window and the variables. You can also create arrays using colon operator in the following way. So if I want to create an array with values containing 1 to 10 and containing a space of 1 between each of them, I can simply make use of colon operator. So you can see the output array we are getting. And if I want to provide a step size between the starting and the ending element, I can simply write 1 colon 2, which is the step size, and 10 is the last value. I will get elements which are in the range of 1 to 10 with a gap of 2 between them. So you can see I got 1, 3, 5, 7, 9. And similarly, if I want to get from 20 to 1 in a step size of, let's say, -3, I can define it like this. And you can see my matrix will start with 20 value and end at 2. Another way to do this is I can make use of linspace function. So in linspace, what I can do is I can specify the starting and the ending value. 1 is the starting value, 20 is the ending value, and I can define how many number of elements I want in the array. So if I write 10, the values I am getting are these. So main difference between linspace and using colon operator is we can specify the starting and the ending element in this and can generate random values as well. Another operation we can perform on the matrices is the transpose function, and that we can do simply by defining B is equal to A transpose. So you can see that another matrix B, which is a column matrix now, column array now is created. In MATLAB, we can also make matrices containing zeros over ones or random values in the following way. So if I take another variable and define it as zeros, 2 comma 3, this will return me a matrix with 2 rows and 3 columns and containing zeros in it. So these type of matrices help us when we are working with image processing. If we want to make a padding of zeros around the image, then we can do it in the following way. Similarly, if I want to create a matrix of ones, I can write it like this, 4 comma 5, and I will get a matrix of 1. And if I want to create a matrix with random values and 4 rows and 6 columns, I will define it like this. Obviously, you can also access these variables using the workspace. So if I click on B, you can see these values are similar to what we are getting in the command window. Now to access the elements, like if I want to access a single element, I can simply write first row and third column and I will get the output. But if I want to do this operation for multiple rows or multiple columns, I can do it in the following way. So in case I want to access all the element of first rows, I will write B1 comma colon. So this colon here means all the columns which are present in row 1 should be printed. And you can see the values from 0.81 to 0.6557 are printed here. We can do selection in a particular range as well, like B2 comma 224 224. So this will return me the values in the second row and column number 2 to 4. So 0.975 to 0.4854. Or if I want to access particular elements, I can do it this way. Row second, and I want the element number 1 and element number 3. So you can see I'm getting 0.9058 and 0.94964 now. And if we want to get values in a particular range, say, let's say, I will clear my screen first, print P again, and now to access element in a particular range, so B1 row first, and I don't know the end value. So let's say I know there are 6 columns right now, but if I don't know how many columns are there, I can simply write 2 to end, and all the values from second column to the last column will be printed. Similarly, I can write B and -1 and all the rows in it. So this should return me the values from row number 3 and all the columns in it, and that's what we are getting here. Another interesting operation you can perform is you can delete the rows in the 2D array, and that you can do it by equating it to a blank matrix. So if let's say I want to delete rows 1 to 3 and I want to delete all the columns in it, I will simply equate it to a blank matrix, and you can see only the last row remains in the matrix P now. So now let me clear my screen once again and again make a random matrix, random 3 rows, 7 columns. So this is my B matrix now. One thing I want to tell you is that matrices in MATLAB doesn't have an index 0. So if I write B0, it will throw me an error. So array indices must always be positive integers or local logical values in MATLAB. This thing becomes important when you are working with loops. So generally what we are used to is we will start the loop from I going from 0 to n and we will increment it by 1. But in MATLAB, you cannot do that because the array indices always must start from B1. As I mentioned earlier that the internally the matrices or the arrays are stored in column fashion in MATLAB. So this column will occupy first three place, then fourth place will go to this, fifth to this, and sixth to this. So to assign these values to a new array in a column fashion, we can simply write B column, and this will create the matrix in a column fashion. So you can compare the values 0.6787 till 0.731, these first column, then they will start with second and so on. Now you can perform logical operations on the array as well. So if I create a new matrix with assigning values b less than 0.5, we will get a logical array and all the places where the value is less than 0.5 will get 1, and the ones which are having larger values like 0.7 are converted to 0. We can use this for doing matrix manipulation as well. So if I want to say like E a new array to have E all the indices which are less than 0.5 to be converted to true. So this will throw up an error because of two equal to signs, but I can do it as 2. So it seems like the A was always already having 1, so this statement is always true. A1 less than equal to sorry, this statement is always false, so hence no value was changed to 2. But if I do this for b less than 0.5, so b was a random matrix and it will have values less than 2. So these values like 0.3922, 0.712 should be converted to 2. And you can see those are converted to 2. And if we want to see the indices where the particular condition is true, then we can make use of find b less than 0.5. So this function will return all the values which will have less than 0.5, but since we changed all the zero point 0.5 values less than 0.5 to 2 in the previous operation, we are getting an empty matrix here. So what I will do is I will clear all the variables once, and I will create another variable p with random values and size of 4 to 6. And now I will again make the command find b less than 5, and you can see we are getting the column numbers where the values are less than 0.5. So here value is less than 0.5, we are getting 1, this is 2, and then this is the sixth, which is shown here. So if you want to get the values in the format of rows and column, we can do it like this: row, column, and find b greater than 0.5, and we will get the row and column numbers for that. So how you can read is the third row, column 1 is having a value of greater than 0.5, which is this value. Few other operations you can perform on the matrices, and these are usually very helpful when you want to find out how long or how many times a loop should be running. So I can simply print the b. I will ask MATLAB what is the length of the array b, and length and width should give me the same result, which means the number of columns. And if I want to see how many rows are there, I can ask the MATLAB what is the height of b. Another way to access the height and the width information, we can simply print the size of matrix B, and we will get 4, 6. So these are always placed in number of rows and number of columns. So size b comma 1 should return me number of rows, and that is 4. Another thing we can ask MATLAB is how many uh, numbers or elements are there in a matrix by using numel function. So numel b will return me how many elements are there in the matrix, that is 24. Another set of operation we can do is simply concatenate two matrices. So for example, I want to create a matrix named mat, which is having B as the matrix placed one by one, side by side, and I can print it in this way. And if I want to place them one above another, I can simply make use of the semicolon function. So these are some of the basic functions we can perform on arrays. You will be working with arrays no matter what toolbox you are working with. The results are always stored in a form of a array or matrices, and you will always perform operation on these values even if you are plotting a value or if you are making some decision based on the values which are present in the matrix. So these operations will always be helpful.